This is Mr. Gillum, and today we're going to go on to graph some more exponential growth functions. And today we're going to learn a few tricks on how to graph them. All right. And exponential growth functions are in the form y equals a times b to the x minus h plus k. Okay. So this is important to remember. Okay, this little equation here. And same idea. Okay, with all the h's and k's. It always moves the graph left and right or up and down. Okay, so the h value moves the graph left and right, the k value moves the graph up and down, okay? But it's going to be a little harder today because it's going to be hard to remember where to start. What you're going to do is you're going to start at the a value, okay, on the y-axis. The a value on the y-axis, and then move from there, okay? So yesterday in the notes I really stressed that there was really two numbers here, an a value and a b value that had an exponent on it. Okay, that's really important because if there's just one number, you know the a value is 1, all right? And I'm going to show you here why we're moving from the a value here in a second, but you will see. So here's what we're going to do, okay? And these are step-by-step directions, so hopefully if you do get lost, you can come back to them. So I'm going to explain them real quick, but hopefully after we do an example, it'll help you remember. Okay, so we're going to draw a coordinate plane. Put your pencil on the y-axis on the a value, and I'm going to show you why that is here in a second. Okay, you're going to move left and right, the appropriate number, okay, depending on what h is. You're going to move up and down, whatever the k value is, okay? That's exactly what you think it is. H is the opposite of what you think it is. You're going to put your point there, and you're going to label the asymptotes. Now, your asymptotes move with your k value. So yesterday, all our asymptotes were at 0. Okay, today, I'm telling you right now, the k value determines where your asymptote's at. All right, so we're going to make a t-chart with two values on either side of the point and connect the points, and we're going to label domain and range. All right, and it's going to be a nice smooth curve just like yesterday. It's going to be exponential growth. All right, and so here we go. Let's take a look at one. Okay, we're starting, and we have the equation. It says graph the function, label the asymptotes, find the domain and range. Okay, so here's how I want you to do this today. I'm going to say, just remember to keep in mind before we get going, it's y equals a b x minus h plus k. Okay, so we have an obvious a value, an obvious b value, an obvious h, and an obvious k. Okay, so this one is very straightforward. All these things are here. Okay. What we're going to do is we're going to start at the a value, and here's why you start at the a value. Now I'm going to show you, okay? The a value is your y-intercept before you get an h and k, okay? It is. Let me show you. If I pretend that there's no -1 h value and no -3 k value, and I wanted to find the y-intercept, here's what would happen. To find the y-intercept, x is 0. I know 2 to the 0 power is 1, and 4 times 1 is still 4. Okay, so without an h and a k, like yesterday's assignment, there was never an h or a k. Okay, and you always, if you look at it, you always started at the a value, whether it was 1 or whether it was 6 or whatever it was. Okay, you always started in the a value. And so that's kind of why, because if there's no h and k, it's the a value that's left over, because anything to the 0 power is 1. So take from that what you want to take from that. But we're going to start at the a value, okay? Because we do have these h and k's in here, they are important. We're going to start at the a value, and we're going to move h and k from that point. So here we go. We're going to say, I'm going to start at the a value, okay? Remember, there's always two numbers here, a base number, b, and an a number, a value out in front. If there's no a value, it's always 1. So we're going to start at a. I'm going to go up, remember this is x, and this is y. I'm going to go up to 4. I'm just going to put my pencil there and just wait for a second, okay? Before I put a point there, I need to move h and k, all right? My h value says -1, but we know about h values is you move the opposite of what it looks like. So we moved up 4 for our a value, and from there, we're moving to the right 1. And from there, we're moving down 3. Okay, we're going to move down 3. So it looks like a point, but it's not a point yet, okay? So we're starting at 4, 1, 2, 3, 4, that's the a value. We're moving h to the right 1, and we're moving k down 3. right there. So that's where we're going to start. Okay, that's where my graph's going to start. Now, my asymptote is going to move with the k value. So before I do anything else, I'm just going to go ahead and label that asymptote. I'm going to say at -3. I'm going to go ahead and put a little asymptote here. It's like a boundary line. I'm going to say that's at y equals 3. Okay, that asymptote's y equals 3. So it goes on forever. You can put little arrows on it if you want. Okay, it's not actually part of the graph. It's just a boundary line that we're going to keep in mind so we don't ever cross that. Okay, and so yesterday, if you think about your homework, the asymptote was always at 0. Well, that's because there was never a k value. It was always 0. Today, though, if there's a k value, that's where your asymptote moves. All right, so just to recap so far, start at A, move left and right H, move up and down K, place your first point. From there, it's very straightforward. Okay, if you can remember those three things. We're just going to make a t-chart, XY t-chart, and we're going to say I want 2 points to the right, 2 points to the left. So I'm going to pick 2 and 3, and 0 and -1. Okay, I got those points from 2 points to the right of my starting point and 2 points to the left. And so now I got to do a little work here. I forgot. Okay, that's fine. Y equals, so let's just figure this one out first. Make sure you do order of operations. If you take 4 times 2 to the first, you'll get 8 to the first. That's not always going to give you the same answer. This time it does, but usually it will not. So 2 to the 2, 2 minus 1 is 1. 2 to the first power is 2. So 4 times 2 minus 3. Y equals 8 minus 3, which is 5. So there's one of my values. Okay, I'm going to move on to the next one here. 4 times 2 to the 5 minus 1 minus 3. Y equals 4 times 2 to the 4th now. I'm sorry, that should be a 3 right there. Sorry, 2 squared. 2 squared is 4, so 4 times 4 minus 3. Y equals 16 minus 3, which equals 13. And remember, we're doing exponential growth, so it should grow really fast or get small really, really fast. So that's a good number to get, 13. Okay, so y equals 4 times 2 to the 0 minus 1 minus 3. Okay, 2 to the -1. Now I'm going to write this one out because this is important. Negative exponents. Let's talk about those. Negative exponents move the value to the bottom. So really this is y equals 4 times 1 over 2 minus 3. And half of 4 is 2. 2 minus 3 is -1. And I'll just make some room over here underneath. Okay, I'll do the last one. Y equals 4 times 2 to the -1 minus 1 minus 3. Y equals 4 times 2 to the -2 minus 3. Okay, remember those negative exponents move the value to the bottom. 1 over 2 squared, which is 4. 2 squared is 4. Minus 3. 1/4 of 4 is 1. So y equals 1 minus 3. Y equals -2. Okay, so I got my t-chart here. And hopefully it'll look like an exponential growth function. Make sure I did my t-chart right. So let's check it out. We got 2, 5. So 1, 2, 3, 4, 5 right there. There's a point. And we have 3, 13. So 3 and then up here somewhere. And then 0, -1. And -1, -2. Okay. So as you can see, it will come really close to the asymptote, just like what we wanted. Okay. It's going to come really close to the asymptote. It's never going to touch or cross today. All right. And I kind of missed the last point there, but you get the idea. Okay, connect your dots and you have your nice little curve here. So we did a lot of work for that graph. We're going to talk about domain and range here in a second, but one more time. We started at 4. We moved to the right 1 and down 3. We put our first point. Only thing left to do, t-chart with 2 values to the right and left of that point. Solve for the work, point the plots, connect the dots. Okay? Now, we got this nice looking graph here. We need to talk about domain and range. Now remember, domain is anything to the left and right, from smallest to biggest. Now, I see that it goes to the left forever, and it'll actually go to the right forever too. It'll be a really, really big number, but it will go to the right forever. Okay, it's continuous. So I'm going to say the domain is from -infinity to +infinity. Okay, it's all real numbers. There's no gaps, there's no nothing, okay, from left to right. Now the range, now here's where things change a little bit from what we did last chapter. The lowest point, okay, is going to be 3, but it's not ever going to come to 3. It's going to come very, very, very close to 3, but it won't actually touch 3. So I'm going to actually have to use a parentheses because I want to use 3 as my boundary, but I don't want to include it. Okay, that's the lowest point on the graph. It's going to get all the way down to 3, but it'll never touch 3, just really, really close. Okay, the highest point will be positive infinity because it will go up forever. Okay, and so there's my domain and range. All right, so a little different than what we've done for square roots and stuff. Okay, now let's look at another one here. And I want to stress this again, okay? Graph the function, label asymptotes, find domain and range. Okay, there are always 2 numbers here. Okay, remember the form is f of x equals a b to the x minus h plus k. I'm telling you right now, it looks like 3 is the a value. It's not true. Okay, there's a 1 right here. Write it in on your paper. Say it again. There's 2 numbers there. If there's not 2 numbers, b is always the base, so there's always an a in front of that, an a of 1. So make sure you understand that. Write it in big important letters. Okay, do something to where that stands out because that's the mistake I saw a lot last year. Okay, so make sure you understand there's always 2 numbers there, whether they're both written or whether one, the a value is a 1. Okay, so here we go. We're going to start at our a value, which is 1. Okay, I'm going to put my pencil there for now. And from there, I'm going to move to the left one for my h value. Okay, I know it says plus 1, but really we're going to the left one. And we're going up 2, right there. So I'm going to put my first point right there. And I went up 2 for this k value. All right, our k value also tells us that we moved the whole graph up 2. So unlike yesterday, the asymptote was always 0. Today, we're going to be at positive 2. So I'm going to go ahead and put my asymptote in so I don't forget. Okay, and the equation of this asymptote would be y equals 2. Okay, so I'm just going to put that out there so we all know that that's the asymptote this time. All right, now from there, once I have my point, once I've labeled my asymptote, all it is a t-chart. Okay, so one more time because this always seems to be the hard part. The a value. Okay, it looks like it's 3. Really, it's 1. There's 2 numbers there, an a value and a b value. B is the base. See how it has an exponent on it? That's b. So we started at a, at 1. We moved left 1 and up 2. We put our first point. We labeled our asymptote at positive 2. Okay, now we just need to do a t-chart. 2 points to the left and 2 points to the right of this guy right here. So I'm going to pick 0 and 1, negative 2, negative 3. So I'm going to say f of 0 equals 3 to the 0 plus 1 plus 2. Okay, 3 to the first is 3, so I'm going to say 3 plus 2 equals 5. There's a 5 right there. F of 1 equals 3 to the 1 plus 1 plus 2. Okay, 3 squared is 9 plus 2 equals 11. F of negative 2. Okay, now we're going to get into those negative exponents again. Okay, and we have 3 to the negative 1 plus 2, which is really 1/3 plus 2. Okay, so be careful here. 2, 1/3 plus 2 is really 1/3 plus 6/3. Okay, 6/3 is the same as 2, which makes 7/3. Okay, 7/3 is the value I want to see in your t-chart when you practice our fractions. If you don't have fractions, okay, if you have mixed numbers, if you have decimals, wrong. Okay, what I want is 7/3 in there. We're going to start thinking like that. Okay, f of negative 3 equals 3 to the negative 3 plus 1 plus 2. So I'm going to go ahead and say 3 to the negative 2 plus 2. Well, that's 1/9 this time. 1 over 3 squared is 1/9 plus, I'm going to change 2 to 9ths, 18/9. Okay, 1/9 plus 18/9 is 19/9. That's what needs to go in there. So make sure you understand. If you need more practice on fractions, I'm sure I can always find a worksheet for those. Okay, but there we go. We got our 4 points. We're going to go ahead and plot those. 0, 5, right there. 111. Okay, it's going to be up here somewhere. Negative 2 7/3. Negative 2, 2 1/3 ish, and then negative 3 and 9/19. It's going to be even closer to the asymptote. So as you can see, we got this nice exponential growth function. An exponential, keep in mind the word exponential means it goes very, very quickly. It increases very, very quickly. So it will. And as you can see, it does approach the asymptote, but it will never cross. All right, let's just talk about our domain and range. Our domain from the left to the right looks like we're going to the left forever, we're going to the right forever. So I'm just going to say it's all real numbers from negative infinity to positive infinity. The range, the lowest number to the highest number, the lowest number is going to be 2. Obviously, it's going to come really close to 2. The higher number is going to be positive infinity because it does go up forever. However, I don't want to include 2, okay? We've used brackets before in the past for our numbers, okay? It's going to come really close to 2, but I don't want to include 2, so I'm going to put a parenthesis, okay? It might come to like 2.000001, but it'll never touch 2. So from 2 and up is my range, okay? So there you have it. Let's look at a couple more here. We should be getting good at these now. Okay, once again, we have an obvious A, B, H, and K value. Okay, I'll write it above here just again for you to, for my reference, so I can reference this to you. My A value -3, my B value 4, my H value +1, my K value -2. All right, just real quick, I want you to pay attention to this negative in front of the A value. That's actually going to flip our graph to the bottom, just like every other graph we've ever done. Okay, that A value, if it's negative, it usually flips it over the x-axis. So that's what we're going to do. Okay, remember, we're starting at -3 this time. So I'm going to go down to -3. This is x and this is y. I'm going to go down to -3. Just like a line where you start at the B value, it's kind of like the A value in this. Okay, you start at -3, you're moving left 1 for the +1 and down 2 more. Right there, that guy. Okay, move left 1, I start at -3, move left 1, move down 2. Alright, so I put my first point. I'm going to go ahead and label my asymptote real quick at -2. Okay, it tells me my asymptote's at -2. The whole graph moved down at -2. Y equals -2. And now all that's left to do is just plot some points. So let's work through this one a little quicker here. We're at -1 right now. I'm going to pick 0 and 1, 2 to the right and 2 to the left. -2, -3. Let's say f of 0 equals -3 times 4 to the 0 plus 1 minus 2. This is really just 4 to the first, which is 4, and -3 times 4 is -12 minus 2, -14. So there's -14. F of 1, -3 to the 4, 1 plus 1 minus 2. This is really 4 squared, which is 16. -3 times 16 is -48 minus 2, -50. So I'm going to put that right there. Okay, f of -2 is -3 times 4 to the -2 plus 1 minus 2. Well, this is really -3 times 4 to the -1 minus 2, which is really -3 times 1/4, which is -3/4 minus 2. Okay, minus 2, minus 2. Well, minus 2 is really minus 8/4. Okay, 2 is the same as 8/4, so I'm taking -3 minus 8, which is equal to -11/4. That's what I want to see in there, so make sure you're doing it the way I'm telling you to do it. F of -3 equals -3 times 4 to the -3 plus 1 minus 2. This guy's really 4 to the -2, so I'm going to go ahead and show a little less work this time. -3 times 1 over 16. 1 over 4 squared is 1 over 16 minus 2. So really -3/16 minus 32/16 equals -35/16. Okay, and so there it is. Got our points, 0, -14 down here somewhere. Okay, 1, -50 way down there, so I'm not even going to plot that point because it's so far down. -2, -11/4, so that's really like -2 3/4, like right there. And then -3, -35/16, so a little closer to the asymptote this time. So as you can see, we do have another exponential growth. Okay, it's going to get really big really fast. That's why it's exponential. That's why we call it exponential, and it will approach the asymptote. Okay, so we did a good job so far. Now all I got to talk about is domain and range. The domain, furthest to the left to the farthest to the right, okay, from smallest to biggest, everything is included. It goes on forever to the left and to the right. So I'm going to say it's all reals from -infinity to +infinity. The range, the lowest point actually, it goes down forever, so -infinity, to the highest point. Looks like the highest point is -2. However, we know that it's never going to touch or pass through this asymptote. Okay, It's going to come really close forever, but it'll never actually touch. So I don't want to include -2. I'm going to put a parenthesis on it. Okay.